as Nick said, I just retired after 34 years with Imperial Oil, 29 of those doing safety. And retirement is a great opportunity where you can step back from what you're doing on a day-to-day basis and start doing some thinking about what worked and what didn't. When you're immersed in safety every day for 29 years, it's hard to do that. So I had that opportunity last summer. Actually took my kayak, went out in the Broken Islands for 5 days, and I wasn't supposed to be thinking about safety, but started thinking about what is it we need to do in any industry if we're going to be twice as safe in the next 5 years. So twice as safe by 2020. And I had an opportunity to reflect on the journey that the companies I've worked with have been through, and also the journeys that other companies have as well. So that's what we're going to talk about here this morning, is this safety journey. We'll look at where you are on it now, on this particular journey, and what we need to be doing in the next 5 years. So we'll do a little bit of a reflection of what's happened over the last 5, 10, 15 years. So what I want to do is I want to show you what the journey looks like if we graph it out. So the scale up the left-hand side is how many people getting hurt, so the injury frequency for various industries. And what we have on the bottom is the timeline. And what we need to appreciate, for every type of work we do, there's an inherent risk in it. If we do nothing, a certain number of people will get hurt. So the scale up the left side is, if we do nothing, that's how many people in the industry will get hurt. The industry I came from, upstream oil and gas, it was about 10 out of every 100 workers. So one out of every 10 workers would be hurt. You look at your industry, and what was the number for fallers? 1 out of every 3 being hurt. So that's not the way we can function, so we need to do something. So the first something we do is putting the basic safety programs in place, the fundamentals. And being certified, that says, okay, you've got the basics. When you put the basics in place, you do see substantial improvement over a short period of time. And by short period of time in safety, I'm talking 1 to 2 years. So possibly a 50% improvement over a couple of years. And the basics are having a safety program in place, awareness, incident reporting, make sure workers are reporting incidents, making sure the equipment is properly inspected and maintained. But then we hit a plateau, and we need to do more than just that. The second phase that we look at is actually demonstrating commitment to those fundamentals. And what that looks like is not just safety people being involved in it, but supervisors being committed to it as well. Not just a safety program sitting on a shelf, but something that your workers are actually using on a day-to-day basis. And getting more proactive. So instead of just reporting incidents that actually happened, we'll be reporting incidents that almost happened. So getting a little bit deeper into it. And again, you see a certain amount of improvement over a period of time, 50%, you get down to those levels. The next level, now we're going to get a little bit more sophisticated, and we're going to be looking at the safety management systems. Those standards that we have in place that says, this is how we do it all the time. This is how we do it in this industry. Here's how we train people. Here's the procedures we have for operating equipment. And we put those in place and again see improvement. So we've got these 3 stages: the basics, the commitment to the basics, and then safety management system that puts some structure around it. Now, when you look at how industries progressed with that, and this is all industries, you'll see the top performers are somewhere in this range. Total recordable injury rates, 4, and depending on your industry, down to 0.4, 0.2. You think that's possible? Well, in fact, it is. So this is where the leaders are. So you need to go back looking at your company, your particular sector of the industry, and saying, okay, where are we on this, and what is it we need to do to get down here? So based on the numbers that we saw this morning from Rob, says kind of in this range here. So what we'll talk about is, what does it take to get down here? Total recordables of less than 2. So less than 2 out of every 100 workers getting hurt, or 1, or is the ultimate goal actually nobody gets hurt? As we get down here, then we get into some of the finer end of safety that'll help you with that. And we're looking at human factors. Do we really understand how humans fit into the workplace? Do we understand behavior-based safety? And a topic we're going to talk a whole bunch more about today is risk tolerance, understanding why workers take risks. So we're going to explore some of these down here. So the company that I worked for in 2015 had a TRI of 0.4. But the company goal was still to be twice as safe by 2020. And the contractors that work for Imperial Oil, same thing. How do we be twice as safe by 2020? And the ultimate, and you saw it on one of Rob's slides there, how do we have it so nobody gets hurt in the industry? And the first challenge I put to you is, do you believe that is possible? And what I'll tell you is, we have to believe it's possible. Are we there yet? No. Is it going to be really hard work? Yes, it is. But that's always, always got to be our goal, is believing that we can work without hurting people. And you've probably already done it in a number of parts of your business. You've got parts of your business that have gone probably several months without hurting someone. And there's been times where your entire company has probably gone several months without hurting somebody. So we've gone these periods of time, different parts, and it's just putting it all together so we can do that on a continuous basis. So that's the first lesson here. We've got to believe that we can actually operate without hurting people. And it comes from people like the people in this room, the safety people, the managers, believing it's possible, convincing the rest of the industry that it's possible. So that's our first one. We need to believe we can actually do it. Number two, we need to understand the science of human factors. And what human factors are is understanding the relationship between the equipment we use, the management systems and procedures, and the people. There's these three components that we have to examine. So equipment and facilities, working conditions, anything we can touch out there, management systems and procedures, how we do the work, and then the people component. And what human factors is, by definition, is the application of scientific knowledge about those three things to improve their interaction. And interaction, if you've got the sheet in front of you, underline the word interaction or just highlight this area in here. Because when you look at the science of these three things, who is it in industry who understands the science of facilities and equipment? Who would that be? Engineers? They understand how to build everything from a tool to a piece of equipment to a sawmill. So we've got engineers who understand that. So we have people who understand that science. The science of management systems. Do we have people who understand that? Managers? Those of you in the room who are safety professionals, do you know something about management systems? Yes, you do. So we've got people who understand that science. And do we have people who understand the science of people? And who would they be? Psychologists understanding the cognitive, the kinesiologists, the ergonomists understanding the physical. So we've got people who understand all those sciences, but we're still not as safe as we can be. And it's because we're not getting the interaction between them right. And engineers like focusing on building things. Management system people like focusing on management system, and the people like focusing on the people, but not necessarily in the workplace. So the job of the people in this room is focusing on that interaction. And when we look at a piece of equipment, how does the person work that piece of equipment? Where are they standing when they're on the controls? Do they understand the procedure? So it's all about this interaction. So for the industries that you're involved in, the equipment and facilities is everything from the trucks, the bunchers, the skidders, saws, mills, and the natural working environment that you've got out there. And the principle on the human factors is we're answering the question, what does it take to make a safe work site? And it's these three components. So we need good equipment and good facilities. You can't give people a garbage piece of equipment and then hope they don't get hurt using it. So the equipment and facilities have to be good. So that's one component of what it takes to make a safe work site. The other component is the management systems procedures, how we do the work. So an example of a management system is the regulations. It says, here's how you will do work. Your industry standards, here's how we do work. The procedures that you give your workers, here's how we do work. How do we manage change? How do we train people? So these are all the management system parts of it. And we need to make sure that there's integrity around those. We need to make sure that the management systems actually line up with the working conditions. So we've got this combination in making sure that they line up. And then we get to the third component, the people component. And having workers who are well trained, who understand why procedures are in place, who know how to follow the procedures, are committed to having a safe work environment. And a big challenge for the frontline workers is in having workers who remain focused 100% of the time and are never distracted. Is that possible? Had a manager, just before I retired at Imperial, said, safety's simple. We just need the workers to focus 100% and never be distracted. Well, that becomes the challenge. And the same manager, who happened to be an engineer, he said, safety would be so easy if we didn't have people out there. Well, we do have people. That's how we do the work. So in answer to this question, how do we have a safe work site? Good facilities and equipment, good management systems, and people who understand those, and that we fully focus on this interaction between the three of them. So that answers, how do we make a safe work site? So some of the components of human factors, when you start examining it, the model I've put up here is one that I developed for ExxonMobil and Imperial. And there's 8 components of what we consider human factors. Workplace design. How do we actually design a workplace? And you could take a workplace as simple as this. And we say, is this the ideal design for a safe workplace? Just looking at this. Well, it's good, but not ideal. Is this the ideal size of a step for having somebody come up and down? Say, well, not quite right. Are there any tripping hazards here? Well, there's a little bit of cord here. So we look at design of workplaces. Have we built it? We look at accessibility. Now, accessibility here is fairly easy. Accessibility onto the equipment you're using, onto the facilities. How does that look out there? How do people actually get into a skidder? How do they get off a buncher? How do they do that? Can the average human do it without hurting themselves? Can they do it when there's snow on the steps? So accessibility is one component of human factors. The second part is equipment design. How do we design controls on equipment? Is it intuitively obvious that when I push on a lever forward, I expect my machine to do what? Move forward. If it does something other than that, then it's not good equipment design. The third component is the work environment. How do we make the work environment as safe as possible for workers? Now, for your industry, that's a huge challenge because you're the outdoor environment, but in your mills and that, how do we make that work environment safe? How hot is it? How cold? How much dust is in that environment? We need to understand the physical abilities of workers. And this becomes a huge challenge when most of the equipment is designed by engineers. And have you seen pieces of equipment where the worker would need to be 9 feet tall to reach a certain control or observe a certain valve or a gauge? Have you seen equipment where the worker would need to be about this big to be able to fit into a space that they're required to? So we need to understand all about the physical capability, and we need to understand what a human is capable of doing physically. Sprain and strain injuries, has that been an issue for you? Overexertion. So what this blue lifting guy is, and if you request, we can send you more information on it. This is a distillation of all the anthropometric charts that say, here's how the body works. And a simple part of this is just teaching workers where their power zone is. So you see blue lifting guy here. I actually modeled for him. You see the resemblance? And you probably saw the Tom Cruise thing too. The principle of it is when we're in this really good stable position, feet here, the body like this, and we swing our arms from top to bottom, this is a zone called knuckle height, right through here. This is where the body has the most power for twisting, pulling, pushing, lifting. This is where the body has power. And the neat thing when we teach workers this is when you work in this zone, it's highly unlikely you will hurt yourself because your muscles are limited out. So you want me to pull something apart, lift something. If I'm doing it here, my muscles get to a point and they go, just can't lift anymore. So we teach workers how to work in this green zone. When you reach outside that, so when reaching outside knuckle height, now what happens is my muscles can still exert the same amount of force, but all the connecting stuff starts becoming weak. So you said, oh, so when I'm lifting out here, in here, 25 kilograms, no problem. Out here, I should reduce it to 15. Reaching up, down, I reduce them. So this became a really good model of teaching workers who are in physically demanding jobs where their power zones are. And you can significantly reduce incidence by applying this part of human factors. So I wanted to point that one out specifically for the industries that you're involved in. And then we get into personal factors. Is that kind of what your workers look like? Something like that? You get people like this. And so we've got to make sure that the workplace is designed for that. And I'm just showing the physical variance in workers. Do you have workers who are much better at recalling procedures than others? Do you have workers who really can understand some of the complexity? Do you have workers who are probably stressed out there from whatever? Do we have workers who may be impaired by fatigue, drug and alcohol? And human factors addresses all of those issues. And I said there was 8 components of human factors, but you only see 7 there. The 8th one we've added to it is understanding human error, understanding why workers make mistakes. So that's what human factors is all about in our workplaces. Understanding the relationship between facilities and equipment, management system and people, and just showing some samples of what's in the detail on human factors. So that's the second lesson. We need to understand human factors to make our workplaces safer. Now, just like that engineer who said, safety would be easy if we didn't have people in there, well, we do. So we need to understand and be able to answer the question, what does it take to make a safe worker? And once again, we've got 3 interacting circles. To have a safe worker, there's 3 components we need. The worker needs the knowledge, the smarts about the equipment and how to do the work, so knowledge. That needs to be overlaid with the skill. Can I actually do it? So I could read all the books on how to operate a loader, a skidder, a backhoe. I could read all the books and have the knowledge, but then I've got to get in it, don't I? And I've got to feel, how does this actually feel? So that's skill. And the third component is the desire. I may have all the knowledge and skill, but choose not to use it. Or the flip side, a brand new worker coming into your workplace, a brand new worker, do they have lots of this? Yeah. How much of this do they have? See, minimal there. So we're looking for this balance between it. Great example, I love using my daughter Megan. When she was first learning to drive, she was 13 years and 11 months old. And in Alberta, you can get your learners at 14. And all she talked about at 13 years and 11 months old was driving, how she was going to drive and which car it was going to be, and it was going to be a red Mustang, and just all this stuff about driving. This incredible, wonderful attitude about driving. Would she have been a safe driver if we put her in the vehicle? No. Despite this wonderful attitude, no, because she had no knowledge or skill. So then she goes and she studies the book and gets the knowledge part of it and reads up on the knowledge and how fast can you drive and what do you do at red lights and green lights and advanced and all of that. And as she starts growing her knowledge, it reins in the desire just a little bit. Because this car she was looking at was a red Mustang, and it had a speedometer that went up to 295 kilometers an hour. Now as she starts reading the knowledge, she says, oh, in Alberta and BC, you can't drive 295 kilometers an hour. So it was, okay, it's still going to be red, but it doesn't need the turbocharger on it. So the knowledge just reins in the desire a little bit. And then for developing the skill, how big is our skill at this point? Nothing. So we take her down to the arena parking lot early on a Sunday morning and say, okay, how does this thing work? So the first thing you do, you get in, set all the controls, and say, okay, now you're going to press on the gas gently. Now, is gently a skill? Now, in the book, we could give her all the knowledge and say you press with exactly 2.2 kilonewtons of force for 3 inches. That would be knowledge. But how do you learn the skill? You try it. So she presses what she thinks gently, and there's rocks flying. Oh, okay, that's not gentle. Here's how it feels. And then we start driving. Okay, now press on the brake gentle. Okay, just a little bit lighter. So we read about knowledge, but we have to practice to get the skills. And just like today, Megan is a very safe driver because she's got a good balance between those. Keeps expanding on the knowledge, practicing the skills, and reining in the desire, so she wants to be a good driver, focused on it, but it doesn't outbalance the other two circles. Now think about your workers. Do they all have a nice balance there? The new worker, this one would be really big, and those two circles fairly small. And the worker who's been with you 30 years, what does his or her circles look like? Do they have lots of knowledge? Lots of skill? Start losing interest after a while? So that becomes the challenge when we're managing people. And do your supervisors know how to keep the senior worker motivated, keeping this circle big? Do they know how to rein that in for a new worker? So the role of supervision when we're managing the people becomes absolutely critical. And Mike is going to be talking a whole bunch more on that after I'm done. So let me give you an example here. So essentially, knowledge is the head, skill the hands, and the desire the heart. So I'm going to show you a worker here, and I want you to give me a relative size of the knowledge, skill, and desire circles. So we're looking at this hoe operator, and watch him as he does his job, and then we'll make an assessment of his skill, knowledge, and desire. Pretty amazing, isn't it? So in relative size, how big is this guy's skill circle? Huge. Actually, maybe we back up a step first. Would you want this job done this way on your work site? Okay? Okay, so we need to understand. So it's an at-risk behavior, so it's not what we want. But the guy's got skill, incredible skill. He's operating 5 sets of hydraulics, and he's able to do this. What about his knowledge? Tell me something about his knowledge. Yeah, knowledge of what? The machine, right? He knows all about this. He knows exactly what this machine can do. What about knowledge of your safety standards? A little bit lower. And if you look really close here, can you see these things going back and forth in the background? What about his knowledge of proximity to power lines? So incredible skill, knowledge of the machine, but you're saying, oh, he's got some knowledge that he doesn't have. Now tell me about his desire. He's going to get this thing on the back there, isn't he? So huge desire on that. Desire to be a safe worker. So you know it gets a little bit more difficult, doesn't it? But his skill, pretty exceptional. And we always need that balance. Knowledge of rules, regulations, procedures, the skill to be able to do it, and then the desire. Would you want this job done this way on your work site? No. Now another question for you. Would you hire this worker? How many people say no, they wouldn't hire this worker? Show of hands. How many people say no, they wouldn't hire him? How many people would hire this worker? Okay. Now, for those who said no, it's saying, well, I don't want somebody setting this example on my work site. Those of you who said yes, how would you manage this? And this comes... So if you believe you've got strong procedures on your work site, you say, I really need this kind of skill in an equipment operator. I need this kind of skill. We've got good procedures and management systems in place. I think I can have this worker working safely in my work environment. Or the other reason maybe, I've got really good supervisors out there. I've got supervisors who've been through the training. They understand, and they could rein this guy in, and he'd be great for teaching other workers. So we're doing that with every worker out there. We're balancing the knowledge, skill, and desire. And that's what helps us answer that question. What does it take to make a safe worker? And understanding the behavioral approaches to safety. Now, when we get into the desire circle, it becomes complicated as well. Is safety as simple as just giving people knowledge and skill? No, we need to motivate them. Do they apply what they learn? And we get into a lot of the proactive aspects of safety. So just very briefly here, I want to talk about the proactive near-miss reporting. And there's an evolution happening in it. We go back, if you're familiar with the incident triangle, 1931, the first, and said, here's the ratio of serious incidents, fatalities, to less serious incidents, to near misses and proactive reporting. And over the years, it's evolved, and we've ended up most recently with a triangle that looks like that, saying that a 1, 10, 30, and maybe about 600 proactive reports coming in, and that's what good safety looks like in 2016. I want to challenge that paradigm and dig a little bit deeper into it and saying, in 2016, the triangle can no longer be that standard triangle. And for Have a Safe Workplace in 2016, what we're looking at is a triangle that looks a lot more like this, where we're not seeing the fatalities and we're seeing fewer of the lost time incidents, but what we see is a lot more activity on the proactive aspects of safety. A lot more near-miss reporting where workers are telling you when things almost happened. A lot more hazard identification where people know what type of hazards to look for in the workplace. And a lot more identification of at-risk behavior in the workplace. So the traditional model of this equilateral triangle, if we're going to be twice as safe in the next 5 years, the triangle in your company should start looking more like this. More proactive reporting, more identification of hazards, more identification of at-risk behaviors. And things that may not have appeared to be an at-risk behavior in the past, maybe in 2016 we should look at them. A great example. Is this an at-risk behavior on your work site? Does every worker understand that? Because there's hazards. If I keep doing this long enough, sooner or later there's going to be an incident. So do workers actually understand that's an at-risk behavior? Or the hazards. I think in 2016 they do, but up until recently, did workers understand that dust was a serious hazard in the workplace? So we need to keep teaching our workers about this. And the big challenge is creating a work environment where your workers know that you want to hear about this. And they view it as a positive, and that you're actually using this information to make your workplace safer. Do you think you could do that in your organization? Do you think you could get your workers participating so you get more and more information about what's happening out there? Because that is all the things that are leading up to the incidents. And when you can catch them one at a time, the at-risk conditions, the behaviors, the conditions, you create a safer work environment because we can prevent the things at the top from happening. How do you do it? I've got 6 easy steps here. Real easy. Create a positive culture and proactive reporting. Is that going to be a challenge? Yeah, and it's going to need management involvement, and management saying, yes, this is important to me. Teach workers how to identify near misses. Do you actually have forums for it? Do they know how to report them? Create a simple reporting system. Is it easy to use where even the brand new 18-year-old on your work site would know how to report near misses? Do workers know how to observe at-risk behavior and what to do about it? If I was on your work site and doing this, would your workers feel comfortable addressing it, saying, hey Dave, watch out for the hazard, stop walking backwards? So teaching workers how to do that. Is that going to be easy? A lot of challenges there. Visible management support. So when workers are participating, they need to know that the management of the company really expects this type of stuff. And the last one, making sure you're always following up with the workers. When they take the time to report a hazard or a near miss, they need feedback that says, that was valuable to us. So 6 easy steps. It probably took myself and the Imperial Oil Organization about 20 years to master that. Learned a lot of lessons the hard way. And what I've done is, it says down the bottom here, all that stuff I learned the hard way, I put it together in a 4-page document. If you send me a note, this how-to document on how to create this positive environment around near-miss reporting, we'll send that to you. I'll make sure that the organizers here have it and post it wherever you want. So easy to say, difficult to do, but we've got to do it if we're going to be twice as safe by 2020. So lesson 4, getting proactive, predictive, and preventative on safety. And then the final one is understanding why workers take risks. Do we really understand why workers take risks? And this is a question that's been bounced around the safety profession for 20 years. Is it okay, I'm still on? 20 years, answering the question, why do workers take risks? This afternoon, we're going to get into this in a lot more detail. I'm going to give you the 10 influencing factors of risk tolerance so that we can actually get into and examine this. But as a warm-up for it, got some risk pictures up here. Can you see this worker up here? We'll call him a worker. He's on a bicycle, a ledge this big, 500 feet below jagged rocks below. Is that a risk? And why would somebody put themselves in that position? And we need to understand, okay, what was this person thinking? Did he think he's got enough capability he'd never drive off the edge? Or maybe he thinks it's his helmet. His helmet will protect him. But, well, no, that's got limitations. So why would a worker do that? Or this worker, he's got his hand on the cable over a roller. What happens to his fingers if that cable goes tight? They're gone, right? So why would a worker do that? We need to understand those type of situations. So we'll explore those this afternoon. Another worker putting himself between two pieces of rolling equipment. Why would a worker do that? We need to be able to answer these questions in our workplace if we're going to be twice as safe. This one here, we've got two workers involved. One is swinging the hammer, and the other's holding the wrench. Who's the more senior worker? Probably the guy with the hammer. So we need to understand the dynamics of those situations. Do new workers, do they feel comfortable speaking up to a more mature worker and say, no, this isn't the right way of doing it? And here we've got a picture where we've got 12 workers sitting on a beam 58 floors above the street below. Is that at-risk behavior? So we need to understand the group dynamics when it comes to risk as well. Who are the ringleaders? Who are the people who said, oh, this would be a really cool idea. We can do this. Who are the people who said, I don't think this is a good idea? Who are the people who said, what if WorkSafe finds out about this one? Now, this photo, have you ever seen a black and white version of that? Construction of the Empire State Building? I would love to be able to tell you that that's just a colorized version of it, but it's not. That photo was taken downtown Calgary, October 2010. So you see the challenge we've got in front of us when we're trying to understand risk is how do we address situations like that? And if we're going to be twice as safe by 2020, and we've made that much progress in 90 years, do we have a challenge ahead of us? Big challenge, huge challenge ahead of us. So this afternoon we're going to explore these in more detail. We're going to talk about the 10 influencing factors for risk tolerance, and we're going to give you some tips and tricks how to identify it in your workplace, and then what you can actually do about it in your workplace. We'll get into this model in a little bit more detail, but here's some principles that we're going to need to understand this afternoon, and understanding why workers take risks. So this research we conducted, one of the breakthroughs on it was we discovered that there are 3 independent processes that happen in our brain when it comes to risk identification and risk reduction and risk tolerance. So the first part, we have some kind of exposure in the workplace, see up in the top left there, and the first thing we need to be able to do is see the hazard. We need to be able to see it. So the brain can say, I see the hazard. So the tripping hazard, I can see. The object that might fall, I can see it. If I don't see the hazard, I end up right down here at-risk behavior. And once again, the example, just using our simple stage here, if I'm walking this way and I don't see that there's a ledge here, does this look like at-risk behavior to you? Yeah. And it's because I didn't see the hazard. So I need to be able to see the hazard. Can I see every hazard that's in your workplace? What type of hazards are really difficult to see? Electricity? Pressure? Fumes? Is there a way you can help me virtually see them? What can you do for me? Indicator light? Great. Pressure gauge? An instrument? Some kind of detector? So we help me see it so I don't engage in the at-risk behavior. So that's the one part of the brain that works first is I need to be able to see the hazard. Once we do that, another part of the brain takes over, and it's the part that says, do I actually understand how this hazard would impact me? So I see it, do I understand it? So the tripping hazard I can pretty much understand, that, okay, I could fall off here, break a finger on the way down, possibly hit something, damage equipment on the way down. So I see it, and I understand how it could impact me. Or the object that could fall on me. So I see it, I think, okay, I understand how that would impact me. But the challenge on this one is sometimes workers don't understand how a hazard's going to impact them. If I don't understand it, I'm right back down there at the at-risk behavior. So real simple example here. Let's picture a wire, piece of cable sticking out of here. So I see it, I've got the first part, but my perception of it is, the risk here associated with this is, if I grab it, it could cut through my glove, I could get an infection or might need stitches from it. And I perceive that as the hazard. Would that always be the right perception of the hazard? Give me an example when that would be wrong. Live electricity in it. So I see it, and you see me go up and do this. Does this look like at-risk behavior to you? Not because I didn't see it, it's because I didn't understand it. I didn't know that had live electricity in it. So I need to be able to understand what I'm looking at. Now, once I see it and understand it, now a third process happens in our brain, and it's the decision-making process. I see it, I understand it, and then I need to make a decision. Do I go ahead with this job? Do I eliminate the hazard? Do I prevent it? Do I use some kind of protective equipment to make it safer? Or do I just go ahead as is and do that? And that's what we're going to explore this afternoon, is the mental processes that happen through these three stages. We're also going to talk about the 10 influencing factors that are impacting your workers' decisions when it comes to risk. There's 10 of them, and we'll talk about how to recognize them in your workplace, what we can do about it, and then give you some tools that you can, tomorrow or Monday when you're back at work, you can start using these to help you identify risk in your workplace. So our fifth lesson here is we need to understand the 10 influencing factors of risk tolerance, and we have the opportunity this afternoon of taking another full hour and exploring that particular aspect of this strategy on how to become twice as safe by 2020. So, summary on our strategy. What do we need to do? Number one, we've got to believe that we can actually work without injuries. We've got to believe that so that we've got this goal in mind of half, chopping the incidents in half as many people fatally injured, half as many people with lost times by 2020. So we've got to believe it. The people in this room, you've got the challenge of convincing your management and the people you work with that that's actually possible. We need to understand human factors. Answering that question, what does it take to make a safe workplace? Are your engineering people engaged in it, the management systems? And do you, safety professionals and the people in this room, understand that interaction? So that's the second thing we need to do. Third, we need to answer that question, what does it take to make a safe worker? That balance between knowledge, skill, and desire. And do your supervisors, do they really understand their role in that? Fourth, we need to be much more predictive, preventative, and proactive, engaging workers in hazard identification and reporting, near-miss reporting, identification of at-risk behavior in the workplace. And Stephen's going to be talking to you about proactive reporting and some success stories on that just a little bit later here this morning. And finally, number 5, understanding and reducing risk tolerance in the workplace. Simple? Any questions on this? Any questions on anything we've set up here? Absolutely. So with the research we conducted on human error at ExxonMobil, it was a neat group to be a part of because we had a cognitive scientist and a behavioral scientist really helping us with understanding what goes on in our brain. And sometimes it's really, really simple things. Things like color. What does red mean to you? Danger or stop. Does red always mean stop? Does sometimes red mean go? You look at some of your electrical MCCs in the control rooms, and does sometimes red mean danger, which means there's actually electricity flowing through it, which means it's running? So if I've been brought up in a situation where red means stop, and you just give me a red light, which means there's energy flowing through it, I'm probably going to make a mistake. So there's a number of mistakes we make. Some is it's a lack of information. I didn't know what red light, green light meant in this particular organization. Sometimes it's a cognitive bias where, oh, this is how I've always done it. The last time I did this sequence, it worked. Why didn't it work this time? Let me give you a really, really good example of a human error. Use a personal example. A couple of years back, I had a new irrigation system installed, and it's the end of November in Cochrane, Alberta. It's 30 below, and I turned the irrigation system on. Is that a good idea? Probably not, right? The thing's been drained for winter. So is that an error? Absolutely. So, it's the end of November. And this happens to your workers. So I needed water outside for something. I had the voices in my head saying, Dave, you need water outside. And I can't even remember what for. So I went down the basement and turned the water onto my outside taps, because I always leave the taps, I drain them so they don't freeze in the winter. And I turned the water onto the outside taps, and I can hear water rushing outside. And I look out the basement window and say, well, yeah, that's because I leave the taps open, but there's nothing coming out the tap. And then it dawns on me, this new irrigation system I've had installed, this is where the contractor hooked it in, to what used to be the tap to outside. Is that a mistake? Is that a human error? Is that a human error that cost me a lot of money? Yeah. So why did I make a mistake like that? I knew it after the fact. So I'm coming up out of the basement, my daughter Megan, I say to Megan, I just turned the irrigation system on. And she says, duh, don't you know water freezes at 0? So Megan's saying this is a knowledge. I didn't understand that water freezes at 0. So I'm not getting any sympathy from her. So I go upstairs to the manager of the facility, my wife Ivy, and I say, Ivy, I just turned the irrigation system on. She says, didn't you follow the procedure? She's telling me it's a management system issue. I didn't follow the procedure. And there is a procedure how to run it, and right in the procedure it says don't turn your water on when it's 30 below. So did I make the mistake because I didn't know water freezes at 0? Did I make the mistake because I didn't know I'm not supposed to turn it on? The procedure manual said that? Or was it a habit I got into? I made the mistake because this is where I used to turn the water on outside all the time, and I didn't recognize the change. So just an excellent example of a really simple human error, and that type of thing is happening with our workers in the workplace all the time. Now, for myself, and this is just a tip, and anytime we talk about human error, we want to know how to prevent it. On that particular valve in my basement now, there's a tag that I hang on at each fall. And what it says no, not till spring. So, do I know what that means? Absolutely. So I won't make the same mistake again. So just an example of the type of things with human error. And there's about 5 or 6 different biases on why we make error, and we all make them at times. If we can understand that in the workplace, we know how to apply the knowledge, skill, and desire, we can prevent some of the human error. I know that was rather a long answer, but I love the topic of human errors. Any other questions? All right, then. Well, thank you very much.